So hello friends, welcome to my channel Concept with Clarity 1. Today in this lecture we will discuss about the stick diagrams. Okay, so I will try to make this stick diagrams in two parts. So in the part number 1 we will try to see what are stick diagrams, where the stick diagrams are used, and what are the rules to be considered to draw the stick diagrams, and also we will be seeing the how to draw the stick diagram for a CMOS inverter, right? So coming to stick diagrams, like what are stick diagrams? We know like VLSI design aims to translate the circuit concept onto silicon. That is what VLSI is, right? So we will be fabricating more than 1 lakh transistors. Our aim is to fabricate more than 1 lakh transistors onto a single crystal silicon, right? One substrate. So stick diagrams are a means of capturing the topography and the layer information using simple diagrams. Here we will be using simple diagrams to convey the layer information. So here in stick diagrams we the layer information is conveyed through color codes. Okay, we will be having different color codes that we will see now. Okay, through color codes, by using these color codes the stick diagrams are drawn. Also it acts as an interface between the symbolic circuit and the actual layout. Okay, so we will discuss about this layout. Okay, for suppose if an architect is there, okay, if the architect wants to construct a 100-story building, right? So what should he have? Initially he should have an floor plan, right? That is what called layout. Okay, a layout is required to construct a 100-story building, right? Similarly, in order to fabricate and 1 lakh ICs onto a silicon, right, what we wanted to have is a layout. Okay, a layout is there, a layout should be present. What does the layout convey the information to us? A layout tells number of transistors, what is the distance between transistor to transistor, and also where the wiring is there, okay, how the connections are made. So all these things will be there in that particular layout, okay, of 1 lakh transistors, right? So before going to the actual layout, okay, there is one step before the layout, okay, that is called as stick diagrams. We also draw we also convey, like layout means strictly we will be using some design rules. Okay, so what should be the width of the transistor, right? What should be the width of the polysilicon? What should be the difference or distance between the polysilicon to polysilicon, polysilicon to metal, okay, metal to metal, or N diffusion to P diffusion, P diffusion to P diffusion. So many in layout there is a strict design rules, whereas in stick diagrams we don't consider all those rules. Just we draw the layout in the form of color codes, okay, without considering any rules and all. We will be drawing the through using color codes we will be drawing the diagram, right? So it is converting a symbolic circuit to actual layout. Okay, it is the interface, right? So you will be having your symbolic circuit like this. Okay, symbolic circuit, okay, between your symbolic circuit and layout you have an stick diagram. Okay, you have an stick diagram, right? So first we will be having a symbolic circuit, then we will be going for the layout. Okay, so there are some rules to draw the stick diagram. Okay, so we will be seeing what are the rules and all, right? First of all, what does this stick diagram is helpful for us in how? So it shows all the components and the vias, okay, and also it shows the relative placement, only relative placement, not the exact placement. It shows only the relative placement of the components, and also it goes one step closer to the layout. Okay, before layout we draw the stick diagram. Okay, and also it helps to plan the layout and the routing. Okay, now it is nothing but it's a cartoon of the layout. It's just a cartoon of the layout, okay, in the form of color codes. Okay, next, it doesn't show the exact placement of the components. Okay, and also it doesn't bother about the transistor sizes as well. Stick diagrams doesn't bother, right? And also it doesn't bother about the wire lengths, wire widths, right, and top boundaries and all. Okay, so and also any other low level details such as parasitics also stick diagrams doesn't give any information to us. Okay, now by considering all these things, okay, we'll try to draw the stick diagram. Okay, there are some rules to be considered. Let us see what are the rules now. Okay, so before going to the rules, first of all, like I said, by using the color codes we'll be drawing the stick diagrams. There are 4 colors are used. Okay, so for metal we'll be using a blue color, and for polysilicon a red color is used, and for N diffusion a green is used, and for P diffusion brown color is used. Okay, by using these colors we'll be drawing the stick diagram, like we will be drawing the wiring connections, we will be developing the PMOS transistor, NMOS transistors, and also the V in V out interconnections between them. Okay, so now we'll be talking about the rules. So rule number 1, what is the rule number 1? For suppose there are 2 wires. Okay, like I said, we have 4 colors. One is blue, red, green and brown. Okay, blue is for metal, red is for polysilicon, N diffusion is green and P diffusion is brown. Okay, for suppose if you are taking 2 wires of same color, right, that means P diffusion brown and brown, okay, or green and green, poly or poly, red or red, okay, or blue and blue. Okay, when 2 colors of same type are crossing each other, if they are crossing each other, then that is an electrical contact. Even if they are crossing or if they are touching each other, then it is like having an electrical contact. Okay, it represents an electrical contact. You can see here, blue is crossing blue and red is crossing red. Okay, so that means internally these two wires are interconnected. Okay, next, this is rule number 1. Next, rule number 2, if there are, let us say, 2 different colors, okay, red crossing blue, metal and polysilicon, this is poly and this is metal. Okay, similarly you can have metal crossing diffusion, P diffusion. Okay, so 2 different colors, if they are crossing, then there is no electrical contact, between those wires. Okay, if there is no electrical contact, if you wanted to show an electrical contact, then it should be shown explicitly by a black dot. Okay, by a black dot, you can see here, by a black dot an electrical contact is made here between red and blue. Okay, right, this is rule number 2. Next, rule number 3, how to form a transistor by using stick diagram is, for suppose if a poly is crossing N diffusion, that means red is crossing green, then that particular transistor is called an NMOS transistor. And if polysilicon red is crossing brown, that is P diffusion, then that represents an PMOS transistor. Okay, so for NMOS simply red should cross green, and for PMOS transistor red should cross brown. Okay, so this is what. And next, for suppose if there is an electrical contact shown between red and green, okay, or else red and brown, then that is not a transistor, then these two are not transistor. Okay, this is rule number 3. And in rule number 4, there is a demarcation line. Once if you wanted to draw the circuit diagram, if you are developing a circuit diagram using CMOS, then a demarcation line is drawn. Okay, a demarcation line is drawn where all the PMOS transistors will be above the demarcation line and all the NMOS transistors will be below the demarcation line. Okay, so this is called as demarcation line. Okay, so by using these 4 rules we will be drawing the stick diagram. Okay, so you can see here how to draw the stick diagram, a simple one. So for suppose if I wanted to draw a stick diagram for CMOS inverter. Okay, so how does a CMOS inverter look? A CMOS inverter is a combination of both PMOS and NMOS, right? So VDD, this is V out. Okay, I will be giving the V input here, and this is ground, right? So I wanted to draw a stick diagram for this one. So you can see here, in the first step, there are 2 metals taken here. This represents the VDD and this represents the VSS. Okay, and in the second step we'll be establishing the PMOS transistor and the NMOS transistor. PMOS transistor means red crossing green, red crossing brown. NMOS transistor means red crossing green. You can see here, first of all demarcation line, then we will be establishing the transistor. First of all P diffusion is taken, this is P diffusion and this is N diffusion. Okay, then you make it the transistor. Now the electrical contacts are made here, you can see the electrical contacts with the black dots, right, and next red is crossing this one, so this becomes an PMOS transistor. Red is crossing green, this is NMOS transistor now, right. Next you see, just we need to connect the transistors, so with a metal. Now establish the connections here, establish the connections, give the input to A and you take the V out from here. Okay, you take the V out from here. Okay, a simple one. So this is V in and this is V out. Okay, so for our convenience let us draw once again here. Okay, so you see, right, first of all again I will be drawing the circuit diagram for the CMOS inverter, VDD, VSS, this is V input and this is V output, correct. Now our first step is to have the metal, okay, VDD and VSS, first step always. Okay, the second step is to draw the demarcation line. This is the demarcation line. Above the demarcation line all the PMOS transistors should lie. Below the demarcation line all the NMOS transistors will be lying. Okay, now for PMOS transistor just you take this brown. Okay, I have a brown here and red crossing a brown is a transistor PMOS. Next I will be taking a green here and red crossing a green is a NMOS transistor. Okay, don't bother about horizontal or vertical. For suppose green is horizontal and red is vertical, then also it is NMOS transistor, and green is vertical, green is red is horizontal and green is vertical, that is also an NMOS transistor only. Okay, so your NMOS transistor or color codes doesn't you can draw horizontal or vertical, that doesn't bother. Okay, now PMOS and NMOS transistors are made. Now make the electrical contacts. So here I need to have an electrical contact, here I need to have an electrical contact. Now establish the contacts between the transistors. How to establish? I will be taking this one. Okay, and again I will be connecting through establishing an electrical contact through black dots. Now I will be connecting the transistors. Okay, so I can use the polysilicon red and red here. Okay, and I will be taking the metal, so I will be establishing the contact again here. So what we will tell, this is V in. Okay, similarly I will be taking a metal here again, so I will be calling this as V out. Okay, simple one, right. So another point to notice is I can also have here, I have used the polysilicon to connect the I have used the polysilicon to connect between the two transistors. I can also use metal to connect the two transistors, that also correct only. Once you establish the electrical contact by using the black dot, then you can draw through metal also instead of using the polysilicon, which might be costlier than the ordinary metal. Okay, so this is the stick diagram for CMOS inverter. CMOS inverter. Okay, so in the next part we will try to develop the stick diagrams for CMOS NAND gate, CMOS NOR gate, as well as we will be taking one Boolean function to implement the same thing by using the stick diagrams. Okay, hope you understood the concept of stick diagrams. If you understood the concept, please like, share and subscribe the video, subscribe the channel. Thank you for watching. Thank you.